In this question, we're given that f of x is 1 over x minus 2 squared, and we have to prove that the limit of x approaches 2 of f of x is infinity. So, for step 1, we want to find delta. So for this, we're going to assume that n is greater than 0. Now we're going to use the inequality of 1 over x minus 2 squared as greater than n. Now we're going to take the reciprocal of both sides. So we get x minus 2 squared less than 1 over n. The sign became less than because we took the reciprocal of the equation. Now we're going to take the square root of both sides. So we get x minus 2 less than 1 over the square root of n. So this inequality gives us a relationship with delta as x minus 2 is less than delta. So from this, we can let delta equals 1 over the square root of n. So step 2 is to actually write out the proof. So we're going to suppose that n is greater than 0. We're going to let delta equals to 1 over the square root of n. We're going to assume that 0 is less than x minus 2, which is less than delta, which is equals to 1 over the square root of n. So now we're going to square both sides. So we're going to get x minus 2 squared is less than 1 over of n. We take the reciprocal, so we get 1 over x minus 2 squared is greater than n by taking the reciprocal. So from this, we can see that for any positive n, if 0 is less than x minus 2, which is less than delta, which is equal to 1 over the square root of n, that f of x equals to 1 over x minus 2 squared greater than n. It follows that limit x approaches 2 of 1 over x minus 2 squared equals to infinity, because delta equals to 1 over square root of n, and this will decrease as n increases. Hence proved. And for a check, you could simply plug in 2, which would equal to 1 over 0. And we know that anything divided by 0 is equal to infinity.